In this video, we will walk through the architecture of the main components in vLLM. Suppose we have a set of requests and 3 config types. Request configs for each request, engine configs for the runtime engine, and global configs for vLLM settings. vLLM contains different components such as processor, engine core client, engine core, model executor, model scheduler, KV cache manager, and others which we will discuss in the following. When the processor receives requests, it validates them using the vLLM configs, tokenizes the inputs, assigns each a request ID, applies request level settings like temperature, and packs everything into an engine core request object. This is the engine core client, your API's interface to engine cores. It connects to cores and handles retries and failures. There are 2 types: the in-process client for single process, direct engine core calls, and the DPLB async MP client for load balancing multi-process setups when we have more than one engine core on multi-GPUs. The model executor handles all forward passes and begins with 3 setup steps. First, initializing the device by selecting a CUDA GPU, checking VRAM, configuring distributed settings, and creating the model runner and input batch. Second, loading the model by constructing the architecture, loading weights, and switching to eval mode. Third, initializing the KV cache by reading its specification, profiling VRAM to estimate how many blocks can fit, allocating and binding the cache tensors, and capturing CUDA graphs for faster execution. Finally, the system can use either a uniproc executor or a multiproc executor. The model scheduler determines which requests proceed to the next engine step. Prefill requests perform a forward pass over all prompt tokens and are compute bound, while decode requests generate new tokens auto-regressively and are memory bound. The KV cache manager is the heart of PagedAttention. We'll explain its details in the next section. The structured output manager, or SOM, is used for guided decoding and formats model outputs into the desired structure. The output processor converts raw engine outputs into the request outputs that users see. It also handles logging and statistics, as well as queuing and streaming coordination. The engine core continuously processes requests by repeatedly calling its step function. Each step schedules requests to run, executes the forward pass, updates and recycles KV cache blocks, and finally returns the engine core outputs. Let's walk a request through the entire architecture. When a request arrives, the processor first validates and tokenizes it, building an engine core request. The engine core client then sends this request to the engine core, which updates its global state. The scheduler adds the request to the waiting queue and later moves it to the running queue. The model executor performs the forward pass, while the KV cache manager tracks and recycles KV blocks. The structured output manager formats outputs during decoding if needed. The engine core reports ongoing and completed requests back to the scheduler, returning engine core outputs. Finally, the output processor detokenizes and formats the results, and the final response is returned to the user.